David Spieth here with one more flipped classroom math video lesson. 3 tips before we start. First, you can adjust the playback speed faster or slower as you desire. Second, you can pause the video at any point to catch up with notes or write down some questions. Third, you can turn on the captions and read my words on the screen. Before we start today's lesson, I just want to explain my casual attire. This week is Spirit Week at my school, at the Verde Valley School. Special place. If you don't know about it, you should check it out. This week is Spirit Week. Today is Twin Day. So the plan is that all the faculty are going to wear a green Verde Valley School t-shirt and blue jeans. And then we get points for each pair of people who are dressed in this way. So a little later at breakfast, we're going to find out how well we did. So that explains my attire. Now let's talk about the lesson. Today's lesson is using the Goodness of Fit test for binomial distributions. And what we're trying to do here is we have some data and we want to build a probability model so we can make predictions in future situations. So we have some data. So here's our data. And we want to check and see whether it fits. So the example is we flip a coin 3 times and we record the number of heads. So flip coin 1, 2, 3, record how many heads. And then we're going to do this 200 times. So we have plenty of trials. So here is our statement for our situation. Random variable x is part of a binomial distribution. 3 flips, 0.5% chance of a success. Okay? So that is our overall scenario. I'm going to show you some data in a minute. We're going to find our expected values, and then we're going to run the Goodness of Fit test to find out whether this data fits within a binomial distribution. Okay, let's look at some data. So in our experiment of flipping a coin 3 times, there are 4 possible outcomes. There are 0 heads, we can get 1 head, we can get 2 heads, and we can get 3 heads. So somebody did this experiment, flip a coin 3 times, 200 times, so they did 600 coin flips. That's a lot of work. And they got this, 28 for 0, 67 for 1, and so on. Now we add those up. They got to be 200, otherwise we have a problem. So there is that part of your data. So now I want you to think about the probability of getting 0, 1, 2, and 3. Go ahead and calculate that. Now that's actually a bigger step than you might think, and we use the binomial distribution to calculate probability. So if you need to review that, go ahead and do that. I'll also put a link for that process on the calculator down below and my video for that down below. So pause the video for a sec, see if you can jump into that and find these probabilities, and I'll be right back with them. Okay, you can use the calculator to do this. I want to show you how to do this with a list because this situation is simple enough. We're only doing 3 coin flips, so we can actually enumerate the number of outcomes with a list. So that's over here. I just did all 8 possibilities, and in prior videos we talked about ways to make sure that you've got all of them. And if you look at that list, you'll see I got every possibility with 3 coin flips there. And so these are all the possibilities. There's 8 total, okay? So now you know there's 8 total. Now you just have to realize how many ways you can get each of these, divide that by 8, and that will give you your probability. So I'll do the first one. There's only one way to get 0 heads. So that's 1 out of 8, or 0.125. Okay, I'd like you to pause the video, use your list, and figure out the probabilities for the next 3. Okay, so there's 3 ways to get 1 head if you analyze the list. There's 3 ways to get 2 heads, and then we're back again to 1 way to get 3 heads. So when I do my math, I get 0.375, 0.375, 0.125, and indeed, they add up to 1, which is what they should. All the probabilities in any situation always adds up to 1. So now, what I want you to do is figure out your expected values. There's a small critical thinking step here before you do that. See if you can come up with that and then come back. Now, if you remember, the probability of getting a certain outcome in an experiment involving trials is always the probability of that outcome times the number of trials. So I've enumerated that here for 0 heads, 0.125 times 200, 0.375, and so on for each of our 4 outcomes. And then I went ahead and put in our expected values in there. So now we can do a little data snooping. Here's our observeds, and here's our expecteds. Pause the video and think a minute. Make a guess. Does this data follow a binomial distribution or not? And then come back. My guess is yes, because these values are pretty close to those, and then these ones are much higher, close to these. So my guess, before we do our analysis, is that this data does follow a binomial distribution. Okay, now let's get into our hypothesis, the null hypothesis, and our alternative hypothesis. So think about our scenario so far, and go ahead and write, perhaps you can write briefly, write an H sub O and an H sub A, and come back. Okay, here's what I get. The null hypothesis is that the data fits the binomial distribution. This is what we're trying to find out. And so the alternate hypothesis would be that the data doesn't fit. Pretty straightforward hypotheses. Now, I'm going to give you what you need, and I'm going to have you do just that. Find out the answer to this question. So we're going to use a critical value of 7.815 and a significance level of 5%. Now go ahead, get out your technology, and find your chi-square and your p-value, and compare them to these values, and come back with your answer. And if you've never done a goodness of fit test using expecteds and observes, I'll put a link to that calculator video down below as well. Okay, let's see how you did. The chi-square I get is 2.426, and my p-value is 0.4886. Now, there was something I didn't prompt you for. If you caught that when you did your calc, great. You need to know the degrees of freedom for your calculation. And here's what happened to me when I pulled out my calculator. I just left the old degrees of freedom in there from whatever that last calculation was, and I just breezed through and I hit calculate, and I got the same chi-square, but I got a very different p-value than I was expecting. And so I looked back in there, I thought about the problem a little bit, and I realized that I needed to find my degrees of freedom to do this calculation. So let's review that. The degrees of freedom is just the number of categories minus 1. So our categories were the sets of outcomes: 0 heads, 1 head, 2 heads, and 3 heads. So we had 4 categories. So number of categories minus 1 is 4 minus 1 is 3. So when I put 3 in for degrees of freedom, ran the calc again, I got 0.4886. So if you ran into trouble with that on your calculator and you got a different result, what I'd like you to do is pause the video right now before you go on with the lesson and rerun that calc and make sure that you can get 0.4886 for your p-value. So after you do that, then what I want you to do is use this information, critical value, significance level, chi-square, p-value, to decide whether or not you can reject or accept HO, the null hypothesis. Is this data consistent with a binomial distribution or not? Okay, let's see how you did. So here we go. My chi-square is 2.486. That's less than 7.1815. So that means we did not pass the critical value. So that supports the null hypothesis, the HO. So the way to think about that is the critical value is something that if you go beyond the critical value, you can't support the null hypothesis, or HO. In a similar way, our significance level is beyond, our p-value is beyond the significance level. So as long as our result is significant, we can use it. So as long as we exceed the significance level, we also can support HO. So our hypothesis is true. The null is true. So there's nothing weird about this data. It does follow binomial distribution. So what that means is that then we could use that data, or put it this way, that data confirms that our coin flipping experiment follows the binomial distribution, and then we can use that to predict odds in future trials of 3 coin flips. So in summary, this lesson doesn't have a new use of the goodness of fit test. It just is applying it to a new situation to answer the question, does our data follow a binomial distribution? Now that you've watched the video, take a minute to jot down some notes, some questions, or a quick summary of the lesson. You can also re-watch portions of the video that were a little bit challenging the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.